Here we go. So we are going ahead and starting 1-7 today, which is talking about, by the way, first off, has anybody got on my videos? Hey, Jeremy, Hayden, Connor Massey, James. I know this sounds not great, but is it doable? Like, could you get a lesson out of that if you really were absent and listen and pay attention? Could you get a lesson out of it? I just, one parent said that it wasn't very good. Hurt my feelings. And I tried. Yes. Yes. How about we just copy your notes? I can copy her notes and just give them to you. Just pay attention. Okay. So 1-7 today is we're still going to use synthetic division. Our goal today is to find values of zeros of those polynomials, once again, that I talked to you guys about where I couldn't, it was like an x cubed. What's the only way I could factor x cubed? What are the two ways? One. Tell me. Sum of cubes or difference of cubes, right? That's one way because I could factor him in, correct? What's the other way that we had? Where we could factor by grouping, correct? If it wasn't those two choices, would I be able to find the zeros of an x cubed? Okay, no. So we're going to start here with this lovely problem here. F of x equals x cubed minus 5x squared plus 2x plus 8. 1, is it a difference of cubes or a sum of cubes? No. Is this a factor by grouping? If I group the front two and group the back two, would I get the same polynomial after I factor it out? I would, right? Because these guys share an x squared and I'd have to be left with x minus 5, but if I pull out the 2, it'd be x plus 4, so it doesn't factor. Does that make sense? Is everybody there with me? Okay. So with that being said today, I want to still find the zeros, okay? And what we're going to be doing today is using our possible rational zeros. Possible rational zeros. Okay, that's really our goal today. Let me explain this. How many zeros should there be here? 3, right? Why do we have 3? Because the degree is the third power, correct? Can we shut the door? Yes, that would be you. I didn't ask Jeremy. I got it. Okay, so there is 3 zeros. So how many linear factors should I have? 3. Even if they're imaginary, can I write them as a linear factor? Right? Even if they're irrational, like square root of 8, which is 2 root 2, right? Could I write him as a linear factor? I can. But we're going to talk about rational numbers today. First off, what's a rational number? A number that can be written as a fraction. What if it's a decimal? How do I know if it's a can be written as a fraction? If it what? Don't know. Okay. Anybody? Yes? If the decimal repeats or stops. You guys know why if the decimal repeats, why it is 1? Does anyone want to see why? Give me a decimal that repeats. So a third. So we already know that a third is 0.3333 and so on. Correct? You guys agree? I'm going to call him x. How many times do I need to move my decimal until I get rid of the repeating? I just need to move it once. Does everybody agree by that? If I move it once, I get past the repeating. Okay, so watch this. Just pay attention for me. I'm going to times this side by 10x. What do I times this side? 10, right? Because this is x. So this would be 3.3333 repeating, correct? What's 10x minus x? What's 3.33333 minus 0.33333? That's why we can do so. Pretty cool, huh? Anybody ever showed you that? You want to see another one? One. Like 9999999. You want to see how that works? Today we have 0.9999 repeating. And there is a proof saying that this does work. We're going to call him X. So how many times do I need to move my decimal to get past the repeating? Just once, right? Is everybody there with me? So this would be 9.9999, which is 10x, because I multiplied it by 10. That's why moving your decimal one through that. Where do we get there? Basically, that's the formula. Pretty cool, huh? No? Nobody? You guys are jerks. Okay, should we do another one? I'm going to make it up. 324.273434434. Okay, call him X. Okay, now first off, the first thing you guys want to do is multiply it by by 100 to get to here. Does that make sense? So I have if I subtracted those two, would I get rid of all my decimals? I wouldn't. Because if I do 34 minus the 27, it's not there yet. So now, how many spots do I need to get past? 2 more. So forth. So that's an extra 10,000. If I subtract these two, would it now get rid of my decimal? Okay, which is 9,000x, or not 9,900 x equals whatever that sucker is. Come over here and just subtract that for me. Anybody have their machine out? No? Ooh, go. Go. Ready? 3, 2, 4. 2, 7, 3, 4. And when you're done, you ready with that? Subtract. 3, 2, 4, 2, 7. Okay, I'm ready. 3, 2. Okay, and then I divide by 9,900. Somebody put that in and see if you get that decimal up there. Teach you stuff daily. It's kind of cool stuff. Those are the things that always blew my mind. I'm like, this is crazy. I always thought it was cool. Awesome, huh? We can go back to our lesson though. Rational numbers, Cosette said it perfectly. Cosette, what are they again? Numbers that can be expressed by a fraction, which are decimals that stop, or decimals that also repeat. Okay, those are ones that can be written as a fraction. Right? Okay, now let me ask you this question here. This is 3 linear pairs, right? What needs to go here, here, and here to get to x cubed? You guys agree with that? Because when I multiply that through, x times x times x has to be x cubed, right? What if this was a 3x squared, x cubed? What does one of these have to have in him? Somebody has to have a 3 there, doesn't he? Because x times 3x gives me my 3x cubed. You guys agree with that? Okay, but he's not there right now, so I'll hurry and get rid of him. But understand, if it's other than just 1, you still have to multiply it to get there, don't you? Right? Okay, what numbers have to be in here? What are some options? 2, 2, 2. Why does it have to be? Why could you have 2, 2, 2? Because that's a perfect example. But why? They go into 8. 2 times 2 times 2 gives me a positive 8. Can I have another one? 2, 4, and 1. 2, 4, 1. How about -2, -4, +1? Does that work? What is the key thing of it? What's the key thing? It has to multiply to be 8, the last coefficient. So if you ever think about it, guys, what's the zeros of this stuff? It's a factor of 8. This is a factor of 8. This is a factor of 8. So our possible rationals, which is our goal today, possible rational zeros, possible rational zeros come from, if you think about it, because I would subtract the 2. What if there's a number here? I would subtract the 2, divide by 3, if there was a 3 there, right? So it's the possible factors of the constant divided by who? The factors of the leading coefficient. So that's what our possible rationals are. Factors of constant divided by the factors of my leading coefficient. Okay? Those are our possible rational zeros. So in our case, what is our possible rational zeros? What are some choices for us? Well, let's do the factors of our constant. Who was our constant? 8. Who was our factors of 8? Plus or minus, because as I just showed Daniel, I could do plus or minus, right? 1, 2, 4, 8. Does everybody agree with that? Because I could have a 1, and an 8. That times is to be 8, doesn't it? I could have a 1, a 2, and a 4. That gets me to be there. I could have a -1, a -2, and a 4. Every single one. I just put it out there because I don't want to put plus or minus into all of them. Sorry about that with my notation, but thank you. Isn't your daddy from Colorado? Is your mommy? Oh. What's our factors of our leading coefficient? 1, right? So here's our possibilities for our possible rational zeros. 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. 8 divided by 1 is 8. Okay. And then once again, it's plus or minus. So how many choices are there to have possible rational zeros? 8. I have possible 8 choices. Yes? Okay, because once again, what's the factors of 1? Notice, once again, in those trinomial, like the 3, I need to get to a positive x cubed. Could that be a negative x, positive x? So that's a -1. You see what I'm saying by that? Answer your question? Good job. Okay, so here we go. Ladies and gentlemen, boys and girls. My last class was Lucky Sons of Biscuit. They picked a number. We're going to choose 1, 2, 4, or 8, plus or minus. Which one do you guys want to try? Anybody? Put down one out. 4. I heard a 4. I heard a 2. We'll try 4, and then we'll go 2, okay? And then we'll try -2 after. Do you know which one works already? I'm just curious. So what were my coefficients? 1, the 5, 8, right? So the first one I heard was 4. I'm just going off what you guys told me to try, okay? Now, will I always pick a good one the very first time? No. This is a guess and check type of a situation. Okay, so I'm going to try 4, though. 1. 4 times 1 is 4. -1. What do we get there? -4. You suck, by the way. You pick 4. You guys are so damn lucky, I tell you what. It's a factor. Now, are we always going to be that lucky? Little scallywag picked a nice one. Yeah, we had 3 choices out of 8. I mean, yeah, a little less than a half chance. But. Okay, how do I know that worked? Because there's no remainder, right? Remember, that means that this is a point 4, 0 on my graph, isn't it? Because that's the remainder theorem. That's what it tells us, is that this becomes a point, doesn't it? Okay? But somebody tell me this was x cubed, right? So Jaden, what's this? That is a -1. That's very true. I pointed there. But remember, what is the highest degree now, since I divided it by 1 time? X squared, right? Okay. Because you degree 2. That's exactly what I asked. X squared minus x minus 2. What can I do there? There's no more searching anymore, right? Why do I not have to search? Because it's a quadratic, and what can I do with a quadratic? Either A, I can factor, but it's always factor. No, so what if it doesn't factor? What can I do? Quadratic formula, right? Does this guy factor? Factors a -2 that get me to be -1. -2 and 1. Does everybody agree with that? Okay. So this factor to be x minus 2, x plus 1. Who was else? One of my guys? X minus 4. Ladies and gentlemen, there it is. We just found our zeros by looking at our possible rationals that we could have had. Notice, did we find this goal that we wanted to? Could we factor that sucker at the very beginning? No. But we still ended up, without using machine, find the results we want. Okay? Yes? We're good? So notice, what are my zeros? 2, -1, How do you feel, Jules? Kind of interesting, huh? Yeah. You guys are like, no, this is math, Mr. Roberts. Yes.
I think it's
right here?
No, I mean
this?
Right. Yeah.
I factored it. If you recall, I'm factoring. I would say 1 times -2. What's our factors of -2? 1 and 2. Does that get me to be -1 when I subtract them? And then remember, I just chose not to show this because, once again, this is something that should be done. Do you remember this stuff? Group. Group. Hence my x minus 2x plus 1. You with me on that now, James? Everybody good? Okay, I'd like to talk to you about another rule. We're going to use the same problem here. It's called Descartes' rule of sign. I think that's how you say it. If anybody knows how to say it better than I, let me know. Descartes' rule of signs. You good? Well, then that's why it's the time stuff, right? Okay, Descartes' rule of signs. Let's go ahead and write the last function that I had. Okay? Which was x cubed minus 5x squared plus 2x plus 8. Descartes' rule of signs tells us this. It tells us how many positive or how many negative zeros there are. Okay? And you might be saying, how is that helpful? Well, Daniel was a lucky son of a monkey. And he picked a factor that was really nice, right? But is it always going to come out? No. And sometimes you might want to search things to help you to make better choices on which ones to pick for your rational zero drive. Okay? Here's what you do. We look at our original function. We say, how many times does my sign change? What I mean is, when I go from left to right, meaning decreasing to increase, I mean the highest power to its lowest power, how many times does my coefficient value change from a positive to negative or negative to a positive? There's a sign change. Anywhere else? There's a sign. What that tells us is there is 2 or 0 positive zeros. Now you might be saying, Mr. Roberts, there's 2 sign changes and you told me it could be 0. Give me just a second, I'll explain that, okay? How do I find my negative 0? Well, here's what you do. You replace x with negative x. So you replace x with negative x. Kind of like an even odd thing in a way, right? So I come here and I replace x with negative x. And here's what I get. Oh, still minus. Does everybody agree with me on that? Can I show you Mr. Roberts' trick, just so you guys understand, but you got to understand that I replaced it with negative x first. When I replace something with a negative x, when will it change a sign? When it's raised to an odd. Did I say change or stay the same? Change. So when will I change? When will I change my sign? When it's odd powers, huh? No, things with even powers stayed the same, right? So usually what I say is, he going to stay the same or change? Change. Is he going to stay the same or change? Stay the same. Is he going to stay the same or change? Change. Is he going to stay the same or change? You guys see how I still have all the same signs as what they had? Let's just go a little bit quicker, because I'm just asking myself, because if I replace an x with a negative x, the only times my sign is going to change is if it raised to an odd power, right? Even powers will just absorb the negative, won't they? Right? Does that make sense to everybody? How many sign change on this one? There's one of them. So that means what? I have one negative 0. Now, how is that helpful? Why would I ever want to do this? Go ahead, Curly. Tell me why. Okay. Exactly. Like one of the ones I'm going to show you today has 30 choices. There's 15 positive, 15 negative. But as soon as I find my one positive or my one negative, will I have to check any more negatives? Would that be helpful? That just got rid of 14 other choices, didn't it? If I was able to find that one choice. Does that make sense how that could be helpful? Okay, now let's talk about why there's the 0 here. Okay, once again, this was an x cubed, correct? X cubed. How many zeros should there be? 3. What are our options for x cubed? Well, I could have it once. And notice it's only crossing it once, so that's 1 negative, right? How many positive zeros are there over here? 0. I have 1 negative, 0 positive. How many others? I have 2 imaginary. Is 2 imaginary and 1 negative come out to be 3? And why do imaginaries always come in 2s? Anybody tell me? Plus or minus when I take a square root, right? Because remember, conjugate pairs always happen with imaginary numbers or anytime I take a square root. Correct? You guys agree with that? And that's why it could be dropping down by 2, because I could have 1 negative, 2 imaginary, that's still 3 zeros. Or what's our other choice? 1 negative and 2 positive. What was our answer? What was our 0? So I had 4, 2, negative 1. What did I end up with? 2 positives, 1 negative. Descartes' rule of sign will tell us the possibilities that are able for our zero.
So is it only imaginary?
Uh-huh. Oh, whoa, hold on. Let me make sure I answered that correctly. What do you mean by multiple of 2? Let's say it comes out to be 3 negatives. Let's say I have 3 sign changes. So I'll have 3 or 1 possibilities. I always just drop it down by 2. And the reason being is, once again, I have to have room for those imaginaries to come in. So let's play around really quick and just talk about it, just so we can be on the same theme here. Let's say I have an x to the 5th. How many zeros are there going to be? 5. Does everybody agree with me there? And I came up with this choice. I have 1 positive, but I have 4 sign changes. So that's 4, 2, or 0 negatives. So look at these choices. I could have 1 positive, 4 negatives. Does that have to be 5? 1 positive, 2 negatives. That leaves us with what? 1 positive, 2 negatives. That's 3 so far. 2 imaginary. Correct? I could have 1 positive, 0 negatives. So that leaves us with what? 4 imaginary. They always come in groups of 2. That's why we're dropping down by 2. Everybody there with me and understand that? Okay. Let's do another one. And I'll show you also why it's a good thing to have. And to be honest with you guys, I actually start with my zeros right now. Meaning, are they going to be positive or negative? That's usually the first thing I'll choose. And I'll show you why on this problem. It's actually really nice on this problem, and it can help us. Okay, how many sign changes? 0, huh? So why is that nice? I have 0 positive zeros. So now when I have my choices, what if it came out to be the 30 choices? Because they're not plus or minus anymore, I'm down to 15. Just cut myself in half just because there's none of these. So I'm never going to check a positive 0, am I? Does that make sense how that could be helpful? Okay, so let's go ahead and see how many negatives there could be. How do I do so again? I replace all the x's with negative x. So who's going to change? Is he going to change? Yes. Is he going to change? No. Yes. No. 1, 2, 3. So I have options for 3 or 1, negative 0. They're all going to be negative, or I'll only have 1. And then the other 2 are going to be imaginary. But what is that nice also to know? If I find 1 0 that's negative, and then I find another 1, what does that tell me? There's for sure 1 more. Right? You guys see how you could use this? Okay, let's find our possible rational groups. Possible rational groups, or zeros. Sometimes I call them, I just figured this out, pros, possible rational zeros. That's kind of funny. No? Jerks? Okay, how do we find our possible rational zeros? Once again, we look at the factors of my constant. Who's my factors of 1? Plus or minus 1, right? Who's my factors of the leading coefficient? 2. So I have plus or minus 1 and 2, don't I? So what are my possible rational zeros? I have 1 divided by 1, which is plus or minus 1. What's my other choice? 1 divided by 2. So how many choices are there? There's 4 choices right now, but what do I know of those 4 choices? I'm not going to be using 2 of those, huh? Why? Because they're positive. And we already know there's 0 positive. See how these could help us doing this idea? Because now it just limited our choices. Okay, so let's go ahead and see if -1 or -1/2 is one of our zeros. Can somebody tell me my constant? I mean, not my constant, my coefficients. It was 2. Okay. Bryn, which one do you want to choose? -1 or -1/2? I'd choose -1 because we don't want to play with the fraction, huh? Okay, I would do -1. Here we go. 2, -1. What do we get? 4. Oh crap, -2. Thank you, whoever said that. 3, -3. 1, -1. Did he come out? Hip, hip, hooray, we got one. Notice though, this was an x cubed, so what's this guy? X squared. So what do we know about x squared? We can factor or quadratic formula, right? Correct? Or we can factor it because it's the factors of 2 that get me to be 3. 2 and 1. So I need a 2 and a 1. And there they are. Once again, I'm not spending a lot of time on factoring because that's what last chapter was, right? We hit that quite a bit. And if you're still struggling, let me know and I can help you. But that means to let me help you, but I got to not spend as much time on something we've already done. Does that make sense to everybody why I'm not going into that as much detail? Okay, who is my other factor? X plus 1, because once again, he was what? A factor because it came out to be a 0, right? Okay, so what's my 0? I still have multiplicities, because that's still a possibility, right? How many zeros do I have? 3. Now, they're only at 2 locations, but there is 3 zeros, right? Okay, -1, -1, and -1/2. Did I get all 3 of my zeros that were negative? And that was what my possibility was, 0 positive, 3 negative, right? Is everybody there with me? Okay, go ahead and graph this if we wanted to, just for a reminder. Here we go, I'm going to hurry and do so. So I have -1/2, here's -1/2, here's -1. I believe it was a positive 2x cubed, so remember, looks like this, right? Okay, so I'm coming low, crossing because it's only to a power of 1. Oh, that's the wrong one, so that's at -1, so I should be doing what? Bouncing, then crossing, huh? There's a rough sketch of my graph, because once again, this is a multiplicity of 2, right? Yes, yes, yes? Okay. Grab your hand and go, woo! And then you can hear, I can still hear my 5th grade teacher. It's not sexual harassment. I did that one time because I had really long hair. Oh, I was a damn hippie. And I had this long hair and I was comparing it to this girl's and I grabbed her hair and that's all. That's sexual harassment. So if that's how you feel. Oh, we could bond? Should we bond right now, me and you? Yes. Keep finding it. We just bonded. And I usually love playing with this because there's not a lot of this game. We bond. Yes. I got it. That's 1, right? You see the 1? Who bothered you? One time I was at student council camp. I was doing that, and I was going down this whole row of all my student council camp. And I thought this other girl was in my student council. I just looked at her face, and I grabbed her hair, and she turned around. I'm like, this is awkward. Anyway, fun times, right? All right, should we try another one? You ready? Okay. How about something x to the fourth? So can I ask, how many zeros do I have to find this time? I do have to find 4, that's correct. How many do I have to find until I can find for certain what my other ones are? 2, because I'm going to show you in just a minute, because after I do it once, I'm down to x cubed, right? Then I'm going to try x cubed, and if I find another 0, then I'm down in x squared. Now x squared, what can I always find? The other 2, because those are the easy ones. Does that make sense to everybody? Because I can factor or quadratic formula. Okay, let's start with our Descartes rule of signs. I'm going to give you time. Go ahead and find out for yourself Descartes rule of signs. So really quickly, I'm just going to show you this one, and then you guys can do the negatives. Notice we have one sign change, right? So 1 positive 0. Okay, push pause, let you guys find the other ones. Struggle with that because I want to keep going. Okay, here we go. So for the negatives, once again, is he going to stay the same or change? Same, so he's going to be a positive. Stay the same or change? Change. Same. Change. Same. So how many sign changes? 1, 2, 3. So I have what? 3 or 1 negative zeros. Does everybody understand how I got that? Once again, how is that helpful? So as soon as I find 1 positive 0, cut it. Then start looking for negatives. See where I'm going at there? Yeah, that can be helpful. That's probably where I'd start, is my 1 positive. Okay. All right, so let's go at this. Let's find our possible rational zeros. So what's our factors of our coefficient? Not our coefficient, of our constant. 1, 2, and 4, isn't it? Once again, these are constant. Divided by who? Which is factors of the leading coefficient, which is 1, 2, 3, 4, 6, 12. That's fun. This isn't even the big guy that I talked to kids about. But I haven't done this problem at all today, so we're going to have fun with it. What's our possible rational zeros then? Plus or minus 1, 2, 4, because what I did there is 1 divided by 1, 2 divided by 1, 4 divided by 1. Now what do I get to do? 1 divided by 2, 2 divided by 2, 4 divided by 2. But what's 1 divided by 2? A half. What's 2 divided by 2? 1. So do I need to rewrite it? No. Still there, right? Does that make sense to everybody? 4 divided by 2? 2 is already there, so I don't have to worry about it, correct? Let's go with the 3. Do I have to write 1 third, 2 thirds, 3, 4 thirds, right? I have to write all of them. Correct? How about the next one? Who do I get to add on to it? Just the fourth, right? Because 2/4 is a half, 4/4 is 1. Does that make sense? So I just get to add the fourth. How about the sixth? What do I get to do on that one? 1/6. Do I get to add anybody else besides the sixth? Nope, because 1/6 is 1/6, 2/6 is a third, 4/6 is 2/3, which I already have, right? Does everybody understand why I don't keep adding those ones? Then what's the last one? 1/12 is a 12th, 2/12 is a sixth, which I already have, and 4/12 is a third, which I already have. Does that make sense why I don't write all those again? How many opportunities do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I miss one? So I have 20 choices to pick from. If you guys pick this one out of it, I'm gonna be so proud of you. I don't know. I know a fraction can be in here. How can anybody tell me why I know a fraction will be in here? I'll tell you right here. Okay, how many binomials should I have for this guy? 4. Right? How do I get to 12? I can't have them all x's, right? I could have 1 be a 12 and then x, 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 correct? Or 1 could be a 2, a 4, excuse me, a 2, a 6, and a 2. So will I probably have, 2, 6, 1, 1? Because I have to get those multiplied. So will I probably have a fraction as one of my answers? Probably, huh? Okay. All right, let's see if you guys can randomly pick out of general situations here. Did you find one, little stinker wing? Okay, here we go. What's my numbers here? 12, 14, -5, -14 again. Okay. -4. Okay, I'm going to quickly show you guys a trick. First off, add your coefficients together. 12 plus 14 is 26. Oh, don't use a machine, you pansy. 12 plus 14 is 26. Minus 5 is 21. Minus 14 is 7. 7 minus 4 is 3. That tells me 1 is not a solution. If you add your coefficients and it equals 0, put 1 through it and it'll work. And the reason being is because 1 times the answer is that answer, and then you add it, it'll just stay, it'll add them all up anymore. Okay? So, -1/3, that's our choice. That's what you said, Daniel?
Yeah.
Oh, hell. I hope we mess up, to be honest. I kind of hope we do. Just because I want you guys to feel that you're not always going to get it right the first time. Because then you might be well, when I went home, I couldn't find it on the first 2 tries. Well, no, duh. Because it's just, it happens sometimes. Now, if you try 4 times and you can't find it, jump on your calculator to find it. Because I don't want you to keep trying, but understand, give it a shot. On your test day, am I going to give you these things, though? I'm not. So you can't just go search them. So, -1/3, Daniel says, which is going to suck. Because it's not going to work, or whatever. Daniel said it should. I'm just teasing you, Daniel. -1/3 times 12. -4, which is 10. Look at this one. -1/3 times 10. Yep. Blame Daniel. -10/3. So that's -5, so that's -15, so that's -25/3. Ninths. It was thirds. Don't be mocking me. Oh, you scallywagger. How did I get that? Do you want me to show you? This is -15/3. I know. Keep busting through for me. So this becomes 25/9, which 14 times 9 is 126, -126/9, which is -101/9. That's your fault, Daniel. This is 101/27, which is this is -81/27. No, it isn't.
No, it's not. It's
Dang it.
It's 4 times.
What is that?
108.
108.
Or maybe you're right.
-108.
Never mind.
So that's -7. Oh, that's good though. Hey, you guys might not like it, but I do. I'm going to tell you why. Did that come out nice? Was that hell? I just met the devil himself right there, guys. Okay, it was that bad. Okay, so with that thing, sorry if you guys offended anyway there. Not really. I have fun with this stuff. Okay, so with that being the case here, what's the point? Because that's a point, isn't it? Isn't that the point? Negative a third, comma, negative 7/27, right? Okay, what was the other point that I went through that I didn't do the work though? I came out 1,3. Why is that important? Why were those mistakes still okay to help us find something? Nope. Let me plot these 2 points on the graph. Here's 1,3. Here's negative a third, negative some crap down here. What's important about that? There's still a lot of choices, but there's a 0 in there. There's a 0 between negative a third and 1. Because remember how I put I added the coefficient? That's like putting 1 in. Here we go, ready? 12 plus 14 is 26, minus 5 is 21, minus 14 is 7, 7 minus 4 is 3.
So that's
It's basically putting 1 through.
Okay.
But notice, ladies and gentlemen, I know there's a 0 in there. Now, is there still a bajillion choices to find that 0? Yes, because notice, let's go back up here. So in between negative a third, we could have a fourth, a sixth, a 12th, plus or minus on any of those. So I still have 6 choices to pick from, but at least I'm down to 6 choices instead of that many. You get what I'm kind of going at there? Yes, no, maybe so. Hooty hotty, hey. Yes, no, you guys all suck and you're not talking to me. I love it. It's my 3rd favorite day of the week. You know my first day? No. I love a Good Friday. Then I get to go home. Usually at night I get to tell the whip we're going out to eat. And then I love a Happy Monday. I love getting back to the routine. I love waking up being ready to go to work. 5 every day. Except on why? Gotta be here at 6 every day. Do you have to be here at 6 every day, Hadley Parker? All right, so anybody just want to find a nice one so we can go through it still? Well, anybody want to just use their machine and just tell me? Just because I don't want to spend a bajillion time searching, to be honest, I don't. Okay, I'm going to try one if you guys are that slow. 12, 14. I'm not going to try a half. I could try a 6th. I could try a 4th. Let me see a 4th. Negative a 4th. No. 4th. No. What do you got? That one's not fun. Another one? No, because it's not repeating at all. All those would repeat really nice quickly. Oh, crap. All right, guys, I just gave you one that doesn't have nice ones in it. We're skipping. I'm glad I really did this problem for you guys. This one we wouldn't be able to find any of our zeros. Let me tell you why. So what was your choice? What did you get? The one I just found was 0.95603. The one that you did the left one. It's like negative something. Oh, by the way, none of my fractions of my possibilities here. A half 0.5, 0.333, 0.666, 1.333, 0.25, 1.6666, what's 1 divided by 12? I don't know. But none of those are 0.95 or whatever he had. Okay, so those are the only 2 times it crosses. So those are real numbers, are they not? So if they cross the axis, are they rational numbers? So this is actually a good explanation because, once again, these are possible rational zeros. Do we have any rational zeros for this function? No. And that's okay. So sometimes they don't have any possible rationals. Now on your test, will there always be possible rationals? Will there be the ones? Yes, I'm going to tell you right now. I'm not going to just say, ha ha ha, sucker, you looked all this time, there's none of them. Okay? I know I'm a jerk. Okay? Here, we're going to do a next one. This one's a big guy, but you guys will hopefully see something right out of the get-go. That really sucked, though, because I was going to have a good time with that one. I was going to take her on a date, maybe to a movie. I do. Maybe it was my whip. Maybe that was her name in mathematical code. Okay. Ladies and gentlemen, can everybody see what's nice about this one? Not a difference in squares. I can factor by grouping. Look at this, guys. What do these guys share? 36x squared. Which is left with what? X plus 4. What do these guys share? -1 left with. Now, let me ask you guys this question. If you can see that you can factor by grouping, would you ever choose to guess and check through all the rationals? No. Okay. But really quickly, what's one of our zeros? And I'm going to hurry and show you guys that it works. -4. Okay. All right. I'm going to just quickly show you guys that it works. So it was 36, 144, -1, -4. Correct? What was one of our zeros? Because of the binomial that came out? -4, but 1/6 is also 1. It was. I'm going to do -4. Nice, right? And then what comes out? And what is he? He's a difference of squares. And as you're bringing up 1/6 and so forth. But notice that's 6x minus 1, 6x plus 1. Okay. So are they always going to be fun and giggles? No. I want you guys to be aware, though, that you can pick stuff. Okay? Notice that 0 that you chose, that yours was like 0.30, right? Was there still a 0 between -0.33 and 1? There was. There's actually 2 of them. Mine was 0.95. That was in between here and here, but it wasn't just a nice rational one on my previous. Does that make sense? How we talked about that? That still there was a 0 in between. Okay. I'm going to go on. Are you guys feeling okay with that? I just want you guys to be aware. Are you going to probably get frustrated for a minute? You might. Once again, though, I'm letting you know I want you to try 4 times. Reasonable 4 checks. And then after that, if you can't find one, go find one using your calculator. Okay? Does everybody understand how to find them using your calculator? Plug it in the y equals. Go second, calculate. Find the 0. Go left of it to the right of it. You should be able to look for it. Yes, sir. I hope not. It won't be bad. Like the one I did last year had 15 choices. But they were actually pretty easy because I would talk to people about, oh, you should always check one of these. Like one of them they should have checked was a third, and they never checked any of the fractions. Does everybody understand how we talked about on the 14, on this 12, that one of them has to be one of these guys? Well, it didn't come out to be any of our fractions, but one of these guys had to be a 12x, and then this could be like, how do I get to 4? I could do root 2 here and root 2 here, couldn't I? And then this guy be an I and a positive I maybe. Those are possibilities because root 2, excuse me. Shoot, that would be it. I don't know. You get what I'm saying. Maybe you do, maybe you don't. All right, we're going to write a polynomial, and I'm going to tell you x is 3 and 1 minus I. I want you to write a polynomial with those zeros. A polynomial with those zeros. Isaac, picture? Or is it filter? Picture. It is 1 minus I. So Isaac, what is the degree of my final polynomial going to have? 2? Okay, why? 2 zeros, awesome. You may help him though, because that's not right. Go ahead. Always has a plus and minus. Because I didn't give it to you, it's still there though. Right? Who else is a 0? 1 minus, plus I. These guys come in conjugate pairs. If I gave you 1 minus root 3, who else comes along? 1 plus root 3. You're always got to remember the conjugate pairs with things with radicals. And I technically has a radical, does he not? Okay, how do I write him as a linear factor? How do I write him as a linear factor? Thank you, Brady. X minus 3. How do I write him as a linear factor? X minus 1, because I subtract him over, but then I add him over. Well, this guy. Okay, this is very similar to our test, wasn't it? That I gave you 3 zeros and I asked you to go ahead and find them, right? Who would I multiply through first, Connor Massey? I would do the i's. Because what happens when I multiply conjugate pairs, which these guys are conjugate pairs, right? When the i's will get rid of each other. So x times x is x squared. X times negative 1 is negative x. X times negative I is negative ix. Negative 1 times x is negative x. Negative 1 times negative 1 is a positive 1. Negative 1 times I is a positive I. Notice I'm just already putting them in so I can combine like terms. Right? I times x is ix. Notice those guys are gone, and they should be, because that's why we did conjugate. I times negative 1 is negative I. Should be gone. What's I times negative I? Negative I squared, which comes out to be positive 1, which is x squared minus 2x plus 1. And I got to distribute him through. It's tedious, but it's not bad. Yes, ma'am. Thank you. I love you and I appreciate you for all you do for me in my life. Bring you on a leg wrestle. Toe wrestle. I've been practicing my big toes. They're really rock. Amazing. Jerks. They're all jerks. I just want to freaking toe wrestle or leg wrestle, and everybody denies me. Jaden? X times x squared minus 2x squared plus 2x minus 3x squared. I'm just busting through now. Plus 6x minus 6, which is x cubed, minus 5x squared plus 8x minus 6. Is there a lot of opportunity to mess up there, though? Yeah. How can I check to make sure that's good to go? Plug in your zeros to be a synthetic. Can I plug in an imaginary? Have I ever showed you guys that? You guys want to see? Huh? All right, here we go. I'm going to show you that you can plug in imaginaries. 1, negative 5, 8, negative 6. Okay? One of our zeros was 1 minus I. Am I correct in that? Here we go. It kind of takes a little bit of time, but just bear with me. This will be 1 minus I, because 1 times that is 1 minus I, yeah? What do we get there? Negative 4 plus, excuse me. I lost it. Now what do we do? 1 minus I times negative 4 minus I. You ready? Here we go. 1 times negative 4 is negative 4. With me on that. 1 times negative I is negative I. Plus 4i, so I have a 3i. I had a negative 4 at the beginning. Negative 1 times negative 1 becomes a positive I squared, which is, I messed that up. Negative I times negative I is a positive I squared, which is negative 1. So I have negative 4 minus I, which is negative 5. You'll notice here, what are these guys? What do I add that to be? It becomes 3 plus 3i. 1 times 3 is 3. 1 times 3i is 3i. Negative I times 3 is negative 3i. 3i, negative 3i, gone. Done. So I have a 3 here. Negative I times 3i, that's negative 3i squared, which becomes positive 3. 3 plus 3 is 6. I just did all that in my head. I didn't do it off to the side. Okay, what do we get there, though? Does it show it's a factor? Who else comes along? If he's a 0, who else is a 0? 1 plus I. Let's try this. 1. 1 plus I times 1. 1 plus I. Then I get negative 3. Gives me negative 3 minus 3i, which is 0. Ladies and gentlemen, this was an x cubed. What's this guy? X squared. What's this guy? So this is the same thing as x minus 3. Is our other 0. Pretty cool, huh? So you can do it. Is it tedious and long? Takes a little bit of time, right? Just be careful. Right, Kaylin? Did you get your calculator yet? Did you get batteries? Silly rabbit. That's all I got for the day, ladies and gentlemen. Okay?